All right, this is lesson 6, inverses. So in this lesson, we're just going to talk about what an inverse is and how you create an inverse from a function or from a relation. So just before we get started, I wanted to go over a couple of key concepts so that when you're finding inverses, you don't have to worry about these starting ideas. So first thing, just a quick reminder that if I have y equals x squared and y equals negative x squared, this negative right here tells us that it is a reflection. Okay, and the negative in front of the x squared tells us it's a reflection in the x-axis. Okay, so I just want to remind you that inverse doesn't mean negative. Okay, so this is a reflection, not an inverse. All right, the second thing is right here. If I ask you to solve for y, so first thing you have to do is square root both sides. So what we end up with is plus or minus root x equals y minus 4. Okay, so you have to have the plus or minus because it could be either answer. And then when we solve for y, we have to add 4 to both sides. So we have plus or minus root x plus 4 equals y. Okay, so just some things to keep in mind as we're going along. The other thing to remember is all these definitions we've talked about. So a relation is any relationship between two variables, whereas a function is a special type of relation where every value of x only has one unique value of y. Right? So you still have to be thinking about functions when we're talking about inverses. Also, just a reminder, the domain is all possible x values, and the range is all possible y values. So an inverse is the same points as a relation, but what we do is we swap the x's and the y's. Okay, so all of the x's and y's are reversed. And you can also find the inverse by switching the domain and range, because the domain is the x's and the range is the y's. Okay, you'll notice from this picture that I have a dotted line drawn at y equals x. So when we're drawing the inverse, that's the line of reflection. Okay, so it's different than a vertical reflection in the x-axis or a horizontal reflection in the y-axis. When we do the inverse, it reflects over this diagonal line, which is y equals x. When you want to find the inverse, okay, what you do is you switch the x and the y. So if I'm given this relation here, so it's 4 points, negative 3, 5, 0, 3, 2, negative 4, and 4, 3, right? And you guys know that every bracket it's x and then y. So to find the inverse, I have to switch all of my x's and then switch my y's. So the first coordinate, instead of being negative 3, 5, becomes 5, negative 3. Okay, the second coordinate is 3, 0. The next one's negative 4, 2. And the last one would be 3, 4. Okay, if we want to sketch the original relation and the inverse on the same grid, okay, we'll start with the original one. So we have negative 3, 5, 0, 3, 2, negative 4, and 4, 3. Okay, if I sketch the inverse, so that's our new points, I'm going to do them in blue. We have 5, negative 3, we have 3, 0, negative 4, 2, and 3, 4. Okay, so if you look at the graph, just draw a line here to show you. Okay, the line of reflection is right down the middle here. Okay, and you can see that on either side of the green line, the blue and the black lines are the same distance away from the green line, just on opposite sides of the green line. So it's like I'm drawing a mirror down the diagonal and inversing the function across it, or the relation. Okay, the last part of this example is to say whether the original and the function are inverses. So if we look at the original relation, the black dots, okay, we can see that each x has only one value for y, right? It passes the vertical line test. So the original one is a function, right? So the original one is a function, so the black dots are a function. If you take a look at the blue dots, the inverse, you can see that right here, okay, two dots have the same x value but different y's. So that means it's not a function, right? It's going to fail the vertical line test. So not a function. Okay, so that's how you find the inverse. You switch the x's and the y's. Okay, the inverse of a function sometimes is and sometimes is not a function. So the last example, right, the original relation was a function, the inverse is not. But if the inverse is a function, then what we do is we call it the inverse of f, or f inverse, and we write it like this, okay, right here. So f, -1, and then x, right? So we read this as f inverse, or the inverse of f. And if you want an example, it's like when we write sine inverse, okay, or cos inverse, tan inverse, right? That doesn't mean it has an exponent of a -1. That's just how we write inverse in math. So when I write f to the -1, it's actually the inverse of the original function.